Okay, so for those people doing the extension task, hopefully this shouldn't be too hard. It just requires a little bit of thinking. So they've given you the universal set right up there because it says elements and you've got your universal set. Obviously, it looks so much nicer than my wonderful epsilon. But that is your universal set. And then they give you the description for A and B, saying that A is the prime numbers coming from that universal set, obviously, and B are the factors of 12 coming from that universal set, okay? So first of all, you probably want to write down what A is. So A is your prime numbers, so it only has two factors, 1 and itself. So it would start 2, 3, 5, 7, and 11. Okay, and then for B, you've got the factors of 12. You might just want to put them in factor pairs. People usually find it easier to have like 1 and 12, 2 and 6, 3 and 4. And then by the time they get to the end of that, they'll be like, well, it's 4 and 3, which is already in the set. Okay, so written down the sets. Now I want to fill out my Venn diagram. Okay, guys, I am going to say if you do this part by yourself, you can do so. You might just want to pause, do it yourself, and then unpause and check to see if it's all okay. Woohoo! Okay, I've just done that and no one can see the thumb. It just looks like it's pointing upwards. Yay! Even though that looks really weird. So with this one, let's pop these into here. First of all, do I have anything that is both in the top and the bottom? So I've got that 3 right there. I've got the 2, and I don't have anything else. So the 2 and the 3 are going to be in here. And then the rest of A is here. So I've got 5, 7, 11. And then on this side, I've got 1, 12, 4, and 6. Okay. But because I have the universal set, I just need to make sure I get the rest. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 8's not there, so 8 is there. 9, 10. 11's in there, and 12 is in there. Okay, so this is what I should see. And then the next step they're asking you to do is just to shade in the true statements, okay? So all you need to do once you've got this is just check to see if they're true. Okay, so it says A has 5 elements. So A is all of this. So 5 elements, 1, 2, 3, 4, 5. That is true, okay? So I'm going to say A has 5 elements. You guys are obviously going to shade this in. I'm just writing down true statements only. Unless you don't have a printer. Okay, B has 4 elements. So B is all of this. So I've got 1, 2, 3, 4, 5, 6. Okay, so that's untrue. And then it says A and B has 9 elements. So A and B is our intersection just in there. It's got 2 elements, so it's not 9. And then it says A or B has 9 elements. So that's this and this. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. A or B has 9 elements. Totally agree with that. And then you have B has the same number of elements as not B. Okay, so this is B. And you got 1, 2, 3, 4, 5, 6. And then not B is 1, 2, 3, 4, 5, 6. So yes, that's true. So B and not B have same number of elements. Okay, then it says B has twice as many elements as A and B. So we already know B has 6, A and B has 2. Okay, so 6 is not double 2. So that's just not true. There are 4 elements in not A. We already know that A is true. A is 5. A is 5. So if your universal set has 12 numbers in it and A has 5 of them, not A is going to be every other number, okay? So every other number would be 7 numbers. Okay, so not A has 7 numbers, not 4. And then it says a quarter of the elements are outside both circles. So I've got 1, 2, 3 on the outside. There are 12 altogether. So 3 over 12 is a quarter. So a quarter of elements are outside A and B. Okay, hopefully that made sense. I was just giving this task so you just reaching a little bit above, obviously, for those of you that are already cracking on with this. Okay, take care. Enjoy the weekend. Toodles.